Okay, we are back. I am continuing my mini lecture about the homework for Chapter 2. In the preceding lecture, we covered 1 through 4. I asked you to do 1 through 6, so I'll do the last two on the same worksheet that we started with earlier today. Okay, so let's take a look at problem number 5 and see what's happening here. Okay, you invest a single amount, and I stress single amount in these, friends, because it helps you decide whether you're going to use tables 1 and 2 or tables 3 and 4. More on that after. I want to give you a couple of guidelines to remember to make sure you always use the right table. Okay, so number 5 says you're going to invest 12 grand, 5 years, 10%. Okay, at the end of 5 years, you're going to take what you've got and invest them for 12 more years at 15%. How much are you going to have after 17 years? Okay, the thing about a word problem, any mathematical word problem, friends, is that people sometimes get overwhelmed by all the words and by all the principles behind those words. You know what you can do? You can, just like we learned in grammar school or middle school, to break sentences down into their components. You do the same thing with a word problem. Break it down, okay? All the pieces are there. Now, if you read this problem twice, okay, you see that it's really two problems in one. All right, you're chasing one answer, but it's really two separate steps. First, you're going to invest a single amount and grow it 5 years, 10%. That's a piece of cake. We've already had practice at doing that. You're given a present value, you're going to find a future value. Okay? But step 2, at the end of those 5 years, now you've got more money, obviously. So you're going to take that and do it all again. You're going to take that amount and you're going to invest it for 12 more years, but this time you get to use a higher percent. You found a way to grow your money at 15%. Okay? So at the end of 17 years, what will you have? Okay, so first we'll do 5, then we'll do 12. Okay, so 12,000, 5 years, 10%. Always write down your facts. Okay, let's attack that one first. When you're doing future value, you know that you're moving forward on the timeline. You use table 1 or table A, future value of a single amount. Okay? Let me see. My answer is going to be on line 11, 5 years. Okay? And 10% means my number is going to be 1.6105. Okay? 1.6105, and you're going to multiply that times how much you start with. $12,000. Okay, I think I got that right. Let me go take a look. $12,000, 5 years, 10%. Yes, I think we're good. Okay, so what I'm going to do is math it out here. Take $12,000 times 1.6105, and my answer is 19,326. Okay, all right. Step 2, I'm going to take that 19,326 and I'm going to grow it for, let me see, where was it? Okay, 12 more years at 15%. Okay? I'll say 12 more years. Try that again. And this time, instead of a measly 10%, my money's going to grow harder for me. I have to go look up another factor in table 1 now, don't I? Okay? So my answer is going to be 12 more years. Now don't use 17 years, okay? These are two separate problems. I'm only doing 12 more years. I'm starting at the end of year 5 and then 12 more years. So I want to use the number that's going to be on line 18. Come way out here and find 15%. It looks like the factor is 5.3503. I'm going to multiply that times 19,326. That's how much I ended with after the first 5 years, isn't it now? Okay, so let's math that out and see what we get. 19326 multiplied by 5.3503, and the number is, looks like 103,399. I guess it's 104,400 more or less, okay? That's the answer. That's how much I have after my total 17 years. All right, now what I'm going to do for you is a proof. Okay, I'm going to take my years. I'm going to take the amount of interest I earn every year. You're going to have to be careful of this one now. And I'm going to keep track of my running balance. I'm starting with $12,000. Okay? All right. So let's come out here, and we're going to start by doing years 1, 2, 3, 4, and 5. All right. My money is growing at 10%. I'm going to take my initial balance, 12,000 that I started with, my present value, multiply it by 10%, 0.1, and I get $1,200. Okay? And I'm going to take that and keep adding my interest to my running balance. So at the end of 1 year, I've got 13,200, and I do that 4 more times. There's my 19,326.12, okay? This time I have pennies. I'm not going to worry about the pennies, okay? All right. Now I want to know what I'm going to have if I then invest at 15% for 12 more years, okay? So let's take that out. All right, this is going to be 12 more years. It'll be 17 years in total when I'm finished. Now I'm just going to change my math up. Here you'll notice that I was multiplying every single year by 10%. Now what I'm going to do is just change that number. I'm still going to take my balance, but I'm going to multiply it not by 0.1, but by 0.15. That's how much you're earning every year. Okay? All right. So I'm just going to put pennies on all of these numbers. I'm going to replicate this for 11 more years. And I'm going to replicate my running balance. And lo and behold, at the end of 17 years, I have $103,399 and change. Okay? It worked. All right. And last but not least, I'm going to do problem number 6. This one you got to be a little careful of. I totally forgot to stop my timer, but I don't think I'll run over this time, so I think we're safe. Okay, let's take a look. Let me save this for you. Problem number 6 says, okay, our friend Bill is going to receive 18 grand a year for the next 25 years as a result of a portrait he's done, okay? And someone wants to buy that right from him, buy it away from him, okay? So someone comes to him with a cash offer and says, I'll buy it for $160,000. Well, Bill's going to receive 18 grand a year for the next 25 years. Someone's offering him cash today. Can you do a valid comparison of money in the future to money today? No, you cannot. Okay? We've already seen this with our lottery example. So in order for Bill to decide whether he's making a good decision or not, he's going to have to discount his $18,000 a year for the next 25 years. This is just like any other present value calculation we've done with one exception. This is an annuity. It's not 18,000 once, it's 18,000 every single year. He has to discount all those payments, 25 of them, to today. Then and only then can he make a valid comparison to cash equivalents, 160, 162.5, 165. So Bill is going to take that guaranteed $18,000, 25 years. It's an annuity. He's going to discount that annuity using Table 4 or Table D. Okay? The present value of a stream of payments that we call an annuity. All right. So we're going to use 10%. 25 years. 18,000, 25 years, 10%. 25 years, 10%, and it is an annuity. It's a stream of payments. I'm not going to call them similar payments. I'm going to say identical payments because I want to stress to you that an annuity means it's always the same dollar number. It's always $18,000. Okay, we're going to come over here to table number 4 or table D. There it is, the present value of an annuity, 10% for 25 years. Okay, my answer is going to be on line 31. I go to the 10% column, and that's my number, 9.0770. I'm going to multiply that factor by one payment of $18,000. Okay, let's see what we get. 9.0770 looks like 163,386. That is how much his stream of payments is worth in today's money, 163,386. So what's Bill going to do? Okay, he's not going to take 160. He's not going to take 162. The cash is not enough to be greater than the present value of all his future payments. He's better with the payments. All things equal, not counting any other extraneous factors like taxation or whether he feels those $18,000 payments will all be received. We don't make assumptions about those. Okay, we accept the numbers on their basis. Bill will not sell out for any less than 163,386, so he would be, all things equal, inclined to accept the $165,000 offer. Okay? All right. Now let's do a proof. We think that that stream of payments is worth 163,386. Now, when you prove an annuity, you have to do things a little bit differently. Okay? You have your interest, but you will also have the amount of payment that you receive, and then you have the balance of the annuity. Watch how this works. All right? We've got 163,386 as what we believe is the present value. Okay? We're going to have 25 years. So let's replicate that number out 23 more times. Okay, not quite enough. Let's take it out 3 more. All right, 25 years. Okay, now if we do this right, friends, by the time we finish and Bill gets his last $18,000 payment, there should be 0 there. That's how you prove out an annuity. Right now, that 163,386 should throw off $18,000 a year every year for Bill, but whatever is in this account is always going to be earning interest. Even as it declines, it will still earn interest right to the very last day. Okay? And it will earn interest at what rate? It will earn interest at 10%. Let's see if it works. So, in the first year before Bill takes any payments, if he had that 163,386 today, it would earn him 10% more. It would be worth a little bit more money. Okay? So let me put 2 decimal places on this. Just like that. Okay, so his 163,386 will grow in the first year to like $176,000. Then Bill takes a payment out of 18 grand. Okay? All right, once again, my Excel is doing funny things to me. There it is. My numbers don't always appear. That's an issue I'm taking up with Apple based on their latest operating system. Now, here's his running balance at the end of year 1. He started with 163,386. During year 1, he adds another 16,338 of interest, and then he subtracts 18 grand. He draws it out. So now he'll only have 161,724 left. That's fine. That money will still make money for him, and it will do so every single year for the next 24 years. Every single year, Bill is going to take 18,000 out. So I'm just going to take that number and replicate that all the way down too. All right, and I'm going to take this formula and replicate it, and I should get 0 at the end. Close enough. All right, I'm off by $7 with a $160,000 annuity. I'm not going to worry about it. What I did is I proved that if Bill has this money in hand right now, okay, then it's going to earn interest at 10% and throw off 18 grand a year for 25 years. So he'll be giving up a financial asset, okay, of 163,386. To compel him to do so, you'll have to offer him more than that. Okay? Offer him less than that, it's not a good deal for him. All right, that concludes problems 1 through 6. I am going to start my series of video lectures for the remainder of Chapter 2, and then Chapter 3, which will represent everything in my so-called Module Number 2, and I'll be making postings onto our My Courses page as well. As always, if you have any questions, make sure you get in touch, and have yourself a great day. Bye-bye now.